Hello everyone. In this video, we will discuss the second case in evaluating improper integral with discontinuous integrand. So in this case, the integrand is discontinuous at the upper limit. Kasi sa case 1, lower limit yung point where the integrand is discontinuous. So if f is continuous in the interval this one, but is discontinuous at x equal to b, which is the upper limit, then this integral of f of x dx from a to b, can be written as the limit of the integral of f of x dx from a to t as t approaches b from the left. So if the limit exists, then we have a value for our integral, and that is the integral will become convergent. While if the limit does not exist, then we say that the integral is divergent or the integral diverges. Okay? So para mas maintindihan, let's try to solve this example. We have the integral of secant x dx from 0 to pi over 2. So since secant x is discontinuous at x equal to pi over 2, we can rewrite this according to case 2 as the limit of the integral of secant x dx from 0 to t as t approaches pi over 2 from the left. Now, we have a formula for the integral of secant x dx. So we can just directly integrate this one. So this is now the limit of the integral of secant x is ln of the absolute value of secant x plus tangent x evaluated from 0 to t as t approaches pi over 2 from the left. And from that, evaluating this one, so this is just the limit of ln of secant t, substitute t first, plus tangent t minus ln of the absolute value of secant 0 plus tangent 0. Okay. As t approaches pi over 2 from the left. Now take note, secant of 0 is just 1. So this is 1. While tangent of 0 is 0. So 1 plus 0 is 0. And ln of 1 is 0. So the whole term here will become 0. So what's left is the limit of ln of the absolute value of secant t plus tangent t as t approaches pi over 2 from the left. Now, as t approaches pi over 2 from the left, what will happen to secant t and tangent t? Para mas makita natin, let's try to look at the behavior of the graph of these functions. So here, let's write here secant of x, ayan, and also for tangent of x. So in this case, let's change the x values by pi over 2 para mas makita natin. Ayan, here is pi over 2. As you can see, as your x approaches pi over 2 or t in our problem, pi over 2 from the left, your function secant t or secant x here is going to positive infinity, or it increases without bound. The same with tangent x, or in our problem that is tangent t, as your t approaches pi over 2 from the left, tangent will also approach to positive infinity. So both will approach to positive infinity. So what will happen to our problem now is ito magiging positive infinity. So we now have, this is ln of positive infinity, and ln of positive infinity will approach to positive infinity. So as the value here increases, the value of ln will also increase without bound. So therefore, this integral is divergent. Okay, so I hope that is clear. Now let's try the second example here. So we have the integral of x over x squared minus 5x plus 6 dx from 0 to 2. Now take note, the denominator is factorable, so we can factor this one. So the factors are x minus 3 and x minus 2, right? Dx. Now take note, when x is equal to 2, the denominator will become 0. So the integrand will become discontinuous at x equal to 2. So again, here, this is discontinuous at x equal to 2, which is our upper limit. So we will use case 2. So for case 2, we can rewrite this as the limit of x over x minus 3 times x minus 2 dx from 0 to t as t approaches 2 from the left. Okay? So from that, the integrand here, we can solve this definite integral by partial fractions, right? If you can still remember. So using partial fractions here, so first, we apply partial fractions. So we have x over x minus 3 times x minus 2. So that is just, so since we have linear factors, that is a over x minus 3 plus b over x minus 2. Okay? Now simplifying, eliminating the denominator, this is just, we will just multiply everything by x minus 3 and x minus 2. Same here. So we have x minus 3 and x minus 2. So what we have is just x na lang equal to a times x minus 2 plus b times x minus 3. Okay? So at x equal to 3, kasi para ma-0 yung b, we have 3 is equal to a times 3 minus 2 plus b times 3 minus 3. So therefore, we have a is equal to 3. Okay? And also at x equal to 2, we have 2 is equal to a times 2 minus 2 plus b times 2 minus 3. That means that we have 2 equal to negative b, or negative 2 is equal to b. Okay? So therefore, this one can be written as the limit of the integral of 3 over x minus 3 plus negative 2 over x minus 2 dx from 0 to t as t approaches 2 from the left. Okay? So from that, we can easily get the integral of every term here. So that is just the limit of, this is 3 ln of x minus 3 minus 2 ln of x minus 2 from 0 to t as t approaches 2 from the left. Okay? So from that, substituting t, so we have the limit of, this is 3 ln of t minus 3 minus 2 ln of t minus 2 minus 3 ln of 0 minus 3 minus 2 ln of 0 minus 2. Okay, as t approaches 2 from the left. Okay, so now here, this is just, ito is just 3 ln 3, while this one is minus 2 ln 2, right? 0 minus 3 is negative 3, absolute value, that is 3. 0 minus 2 is negative 2, absolute value, you have 2. Okay, so we have this for this term here. So ito na lang yung i-evaluate natin. Okay, so as t approaches 2 from the left here, okay, so this will become 2 minus 3. So sige, isa-isahin natin. First one is ito muna. So dito na lang. So we have the limit of 3 ln of t minus 3 as t approaches 2 from the left. We can do direct substitution. That is just the limit of 3 ln of absolute value of 2 minus 3. Wala nang limit. So this is now, this is just 1, so we have 0. Okay, so this is just 0, while this is limit of 2 ln of t minus 2 as t approaches 2 from the left. That is just as t approaches 2 from the left, okay, this will approach to 0 from the right. Okay, so as t approaches 2 from the left, itong nandito will approach 2. So as t approaches 2 from the left, okay, absolute value of t minus 2 will approach 0 from the right. And from that, ln of 0 from the right, so that will approach to negative infinity. So this is negative infinity here. So that means that this one will go to negative infinity, and that is divergent. Okay, so I hope that is clear.